Sometime in the late 90s, IBM sent 12 mysterious workstations to Computer Reset, machines that were never officially documented. And this is one of them, the IBM 7496 Executive Workstation, an incredibly obscure machine from the late 80s. Whether it was a prototype or a proof of concept, nobody seems to know. The vintage computer community knows this machine for another reason. One became infamous after a repair attempt on YouTube went spectacularly wrong, and they've been legendary ever since. These machines became so sought after that someone actually broke into Computer Reset and stole the last two remaining machines. And after I brought it back to life once already, it's now broken again. Today we're doing a complete teardown and repair. That means the full disassembly, diagnosing and fixing the faults, building and installing an XT-IDE card so we can finally install software and games, and taking a closer look at one of the most mysterious IBM computers ever made. This machine doesn't have a hard drive, so up until today I've been loading everything from the diskette drive. That is going to change later in this video with an upgrade, but first we need to fix it. Unfortunately, when I tried to use this machine the last time, it wouldn't boot. So I think we have a faulty drive. I have already removed it from the IBM, so I'll be troubleshooting it with a different motherboard. We'll disassemble the 7496 when we have a working drive and reinstall it, along with some upgrades. So let's see if we can fix it. So if we turn the machine on, after about 30 seconds it makes this noise. It sounds like it's trying to move the heads. And the system is asking me to insert the diskettes. Let's get inside and see what we will find. So it was dead when I got the machine. But if I remember correctly, I replaced the caps. And then it started to work. And now apparently it's dead again. And this, by the way, is an ALPS drive. And apparently it's manufactured in mid-1987. I have disconnected the cable for the heads. So now we can remove the PCB. Oh, this drive has a tantalum. Check out this guy here. It's gonna blow. Just like that cap did on the riser board. Oh, damn! I have some glue on it. Let's scrape it off and check what value it is. 4.716. I think I have one in my stash. And then these drives have 3 caps on the upper PCB here. They are not known to go bad, so I tend to leave them in. But maybe that's a mistake. Okay, so let's remove the PCB and disconnect all these cables. This drive, by the way, is as clean as the 7496 was when I got it. So as far as anyone knows, these machines have never been used. And then we need to remove the shield. On many of these drives, this pad here has come undone and is often floating around inside the drive. So the first thing to check inside these is to make sure that this pad is still glued to the head. And it is. Wow, this is not a common sight. This drive looks absolutely brand new inside. That is pretty unusual. So let's turn the drive around and remove the sled underneath. So the common fault with these drives are 3 leaky caps on the lower PCB. But I'm pretty sure we have replaced them in this drive. So I'm kind of clueless to what the issue is at the moment. And with the sled removed, we can now access these screws. With those screws removed, we can now lift the drive at the back and then push it back slightly. They are often stuck in 2 rubber pads, one on each side here. So a little bit of force might be needed. Okay, and after we have pushed it back, we can now lift the drive up in the front. Now we can pull the drive out through the front. So a bit tricky to disassemble. And if you're playing along, pay attention to the spring here, because it is loose. Before we can turn it around, we need to put something underneath to protect the heads. Oh, I see. Now I remember. I was a bit short on caps when we repaired this drive. So I just grabbed whatever crappy caps I had at hand and installed them here, with the intention to replace them next time I mess around with this drive. Well, I guess that's today, so let's start by replacing these caps. So normally this doesn't really matter. We can use through-hole caps to replace SMD caps. But in this case, these are some really cheap, crappy brand. So that is why I want to replace them. Yeah, these are just marked SLF. I have no idea what these are. So these two othermost caps have the same value. I think they are 1 microfarad, 16 volts, but I'll double check. Then we have a slightly larger cap up here. Okay, but the good thing here is that I don't see any damage to the PCB. So we were lucky and removed the bad caps before they had started to leak, at least enough to cause any damage. So I'll add some flux to the pads and remove the old solder with some wick. Yeah, these pads look good. So the PCB is definitely not damaged by leaky caps. I added a splash of solder to one of the pads. And then I'll just add a new cap. Reflow the solder. The cap in the middle was a 10 microfarad 16 volt cap. And the other two were 1 microfarad 50 volt caps. This pad is a bit hard to reach, so I had to switch to a bend tip. Otherwise I'm risking damaging the motor. Polarity is clearly marked on the board. It is, however, underneath the motor here. So you have to look underneath the motor to see the markings for this cap. Before I put the drive back in the cage, I have to replace that spring. The wires are a bit too short for this test, so I'm gonna have to hold the PCB like this. There goes. Okay, it made that noise again. And the heads moved forward about 2 millimeters. And then it actually made small movement again, but this time less than 1 millimeter. Okay, let's go for that tantalum next. One of these blue guys here put up quite a light show in the floppy drive in the 5155, if you have seen that video. So I'm pretty keen on replacing it, whether it's causing this issue or not. Now this board actually has a bodge here. So this tantalum also has a resistor soldered directly to one of the legs. So we're going to have to put that resistor back on after we have replaced the tantalum. I'll add some fresh solder to both legs first and let it mix with the cranky old solder. By the way, I checked and polarity is clearly marked on the PCB here. I guess we should lift this resistor up first. And then I'll just use the desoldering gun to remove the solder. It has also been glued down to the PCB. So let's cut that glue. Something is still stuck here. It's still stuck to that resistor. Now let's try that again. Off you go, nasty little tantalum. This nasty little blue tantalum is a 4.7 16 volt cap. I'll pre-bend the legs before I install it. I'll solder these two legs first before we take care of that bodge on the other side. But first let's unbend these legs. Let's keep things nice and tidy. Now I'll bend this resistor leg so it touches the leg of the tantalum. Now I can solder that bodge. That tantalum is now a happy cap. Okay, let's see how it behaves. Okay, it made that movement again. Then I actually heard a ticking noise and it tried to move the head again, but it couldn't. Okay. Well, in that case, let's try to move that head manually. I have cleaned the edge connector with deoxide, by the way. Oh, that is pretty stuck. That is actually not moving. But then again, I'm not sure exactly how this drive is designed. But on all drives I have worked on so far, the heads could be moved manually. But apparently not on this drive. So either it's designed differently, or it's jammed. Let's see if that motor spins up. This drive is not easy to work on, because that PCB is installed on top of the drive. Well, it spun up briefly. Let's insert a diskette. Okay, now it's spinning, but it doesn't move the head more than a couple of millimeters. Oh, did I see some magic smoke? Is the camera on? Yes, it is. I think I saw some magic smoke. Yeah, that is definitely magic smoke. Where is it coming from? And it smells really badly. I don't think it came from the board. Okay, I found it. Check out L2 here. It has formed a tiny little black bubble on its side. So that is one dead inductor for sure. Now the question is, of course, was it because it was a bad component? Or was this caused by the heads being stuck? Let's get this guy off the board. Now I'm not sure if we should just replace it. What if something else caused it to burn? Well, it's definitely damaged, that is for sure. It has a big hole on its side. So if I'm reading the colors correctly, we should have roughly 58 microhenry. We're getting nothing. That thing is dead as a doornail. All the magic smoke escaped. Okay, we just got lucky. I found a working drive. So let's borrow this inductor and install it on our cursed drive. But I'm not going to install the PCB in the faulty drive, since it might be what caused that inductor to burn. Instead, I install it in the working drive. I think this is worth testing. Here goes. Well, nothing is burning, and it's counting up the RAM. Heads moved. And it reads. Okay, so that PCB is good. At least with this inductor installed. So if we're lucky, that was just a bad inductor. But we can't be sure. And I don't want to burn more components. So normally at this point, I would just turn the worm shaft manually to see if it's jammed. But on this drive, it's almost completely covered with a cassette. So I can't reach the damn thing. So let's remove these springs here. And then remove the two screws on the side here. And hopefully this will free up the cassette. So you may think it's a bit of a weird diskette drive. But the thing is, 3.5-inch diskette drives weren't really standard on PCs until this machine came out. So I think Alps was kind of figuring it out at this point. Apparently that wasn't enough. So let's remove the bracket on the other side too. See if that helps. I think it did. But we probably need to lift the heads. Yep, here it comes. Okay, so let's see if we can find a fault here. Well, the grease on the worm shaft is actually still soft. Now, I don't remember if I have applied this grease or if this is the original grease. This drive sure is unusual. So the worm shaft here is sitting in this plastic tube down here. So I'm not sure if it should move or not. Oh, it was jammed. It actually made a noise when I started to move it. So was this our issue? Okay, so that wasn't quite right actually. I turned the worm shaft manually and moved the heads all the way forward. And the black plastic tube here wasn't moving. So if it was stuck inside that black tube. Or in the bearing, in the stepper motor. Okay, I think I found a fault here. Check out these two switches on the working drive. When I push on them, they move freely, as they should of course. So if you look at these two guys here, they are stuck in their down position. They are not moving at all, they're completely seized. Now this doesn't explain the burnt inductor, but it could definitely explain why the heads aren't moving. Because the drive doesn't know if it has a disk installed. If those switches aren't working. Let's see if some deoxit is enough. No, they are really badly stuck. So I'm gonna have to open this switch up and hopefully springs aren't going to fly all over the studio. So let's remove that switch and see if this is fixable with the screws removed. I'll try to disengage these tabs, one on each side. Okay, what will we find inside here? Okay, so we've got two plastic plungers with a spring attached to each one of them. And when pushed down, that spring makes a connection to two small connectors down in the switch. Now they are kind of stuck in the middle. Let's try with some more deoxit. And then I'm very gently going to try to lift. Wow, that is so jammed. I can't make them move without using a lot of force. Oh crap, how are we going to fix this? Well, I guess we could try with some machine oil. I know it's a bit risky with plastics, but we can always clean it off later. I'm gonna let it sit like this for a couple of minutes. Okay, I managed to record a couple of minutes without the microphone turned on here. But what I was saying was that I managed to recoil the two springs and reassemble the switch. They are sort of moving freely, but there's way too much friction. So unfortunately this switch here is shot. Very strange fault. I've never had plastics do this before. This switch, by the way, is made by Alps. They tend to do some pretty good stuff. But then again, everyone makes mistakes. My best guess here is that they used the grease that reacted with the plastics. So there was probably some kind of weird chemical reaction that made them merge together. But then I got lucky. I went through my stash and I found a double density drive with dead heads. From what I can tell, the switch is identical to the switch we need. So let's install it. To reassemble the cassette, we need to put some grease on these two tabs. And then put one of these large washers. One on each side. And then one of these smaller ones. And then we need to lift. Not just the heads, but also this plastic rod here. Like so. This side is easy. All we need to do is to put this bracket back on. And install the two screws. The other side is a little bit trickier. So we need to push this piece back. And then we need to push this bit here up. And now I can install the two screws. Let's do a quick test before we continue. Yeah, totally works. And this time I will install the original PCB with the replaced inductor. Okay, here goes. Okay, the heads move to track 0. Let's hit F1. The disk is spinning, but it's not reading. Oh crap. So, two faults fixed. Still not working. That drive is cursed. Okay, things just got interesting here. I grabbed an identical drive here, plugged it in and turned it on. Poof! Up came the magic smoke. So this lid here was on, so I couldn't quite see where it came from. But I think it was from the same corner as the other drive. Oh crap, no visible clues. So the inductor here looks good. The tantalum has not blown. and none of the other components here look damaged. And the caps on the lower PCB here have been replaced. What the heck is going on with these drives? Okay, this drive too is actually incredibly clean inside, but there is a tiny bit of dust here. So this drive has been used, but not much. Okay, so first let's see if we can move those heads manually. No, we can't. So either this is by design, or something here is stuck. Let's see if we can find out. Now the worm shaft actually feels like it's moving freely. So that doesn't seem to be our issue. It's actually very easy to turn. So definitely not stuck. So I think I was on the wrong track. That magic smoke must be caused by something else. I'll turn it and move the heads all the way forward. That way we can test if the stepper motor is working. Because when you turn the drive on, it should immediately move the heads to track 0, which is all the way back. Well, the only thing we can say for sure here is that this can't be caused by something being worn out, because this drive has seen very little use, and the drive in the 7496 is barely used too. So the fault we are looking for is probably caused by age. Okay, the heads are all the way forward now. And here's our track 0 sensor, by the way. So there's a plunger on the heads here. So when we turn the drive on, it will move the heads all the way back. And when this plunger reaches the track 0 sensor, it will tell the drive that the heads are aligned with track 0, and it will stop the heads and it will start to read. So if we need a head alignment, we will move this track 0 sensor in either direction here until it's perfectly aligned. But first we need to find where that magic smoke came from. And here are those switches, by the way, that were broken on the other drive. So if we just put the diskette here, we can immediately see that this switch here is pushed down when we insert the diskette. That way the drive knows that there is a diskette in the drive. And the blue switch here is aligned with a write protection hole here. So it tells the drive if it's write protected or not. If we close that window, it will push that blue button down. Okay, I did a thorough inspection of this PCB too, but I can't see any faults. It actually released quite a lot of magic smoke, so I was expecting to find a pretty badly burned component. And my guess was of course L2, but unfortunately nothing looks wrong here. This PCB and all the components look brand new. Okay, the drive connected to the motherboard. So what I'm expecting to see here when we turn the machine on is that the worm shaft here should turn and the heads should move all the way back to track 0. Now let's see what happens. Okay, it's counting up the RAM. No more magic smoke. The motor turned. Okay, so the motor is definitely working, but it's not moving the heads. Okay, so that's actually bad design. The heads are disconnected here, but that shouldn't affect the worm shaft and the stepper motor. Not as far as I know. Okay, so my best guess here is that one of the components on this PCB here that blew the magic smoke is somehow involved in powering that stepper motor. Quite possibly the inductor L2 here. Okay, we're back at the 7496 drive here, and I've moved the heads all the way forward. Let's flip that switch. And the heads moved to track 0. So that is what we expected from the second drive. And the only clue we have is a faulty inductor on the first drive. So let's remove it on this drive too. Okay, we may have something here. Now this could be flux, but it could also be magic smoke. Same thing underneath the inductor here. This could be flux, but it could also be our magic smoke. So I actually took a break here and ordered an inductor. These guys should be about 56 microhenry, and my new inductor here is about 55. I wasn't expecting to blow 2 of these though, so I only ordered 1. Now let's see if that was a mistake. Yeah, this guy too is dead as a doornail. So the brown spots was our magic smoke. Okay, so we seem to have a common fault with these drives. So I'll go ahead and replace this guy. Unfortunately, it's quite a bit thicker than the inductor I ordered. So I may have to replace it again. I also ordered some more tantalums and replaced this guy here. So hopefully no more magic smoke today. Okay, the spare drive connected with a brand new inductor and tantalum. Here goes. And now the heads are moving to track 0. Okay, in that case I'll reassemble it for a more comprehensive test. Okay, said and done. Let's see how that spare drive behaves. It made a noise, but it doesn't boot. So this drive too has multiple faults. What are the odds? Okay, in that case, let's check if the heads are aligned. The easiest way to check if this is a head alignment issue is to install the suspect drive as drive B and the working drive as drive A, and then boot the machine. And next I'll install a brand new diskette in drive B. And then I'll format the diskette in drive B. Bad command or file name. Oh crap. Let's do that test with the drive from the 7496. I'll boot from a working drive A. Oh, hang on a minute. I just realized my mistake here. That is not a proper DOS diskette. Okay, let's do this test again with the proper DOS diskettes. That was just an empty bootable diskette, but not this one. Yeah, that's much better. Insert new diskette for drive B. Okay, so I have a brand new diskette in that drive. Okay, and the format is running. Oh, it actually worked. This is awesome. Format complete. So this means that the drive from the 7496 is now working. But it has a head alignment issue. I have shown quite extensively how this works in another video, so I'll put a picture on the screen here if you want to watch that video too. And in this video I'll just go ahead and do the head alignment right away. So the short version of this is that we need to move this PCB sideways. And in doing so also move the 0-track sensor installed on the other side of the PCB. So first I'm going to take a Sharpie and mark the position of the PCB. That way I will know how much I have moved it. And the next step is to undo that screw. And now I can just take a screwdriver and push that PCB sideways. That was too much. Just a fraction of a millimeter is enough on each attempt. And then I'm going to tighten up that screw again. And the next step is to see if I can boot the machine from this drive. If that doesn't work, I'll loosen up the screw again and push that PCB some more. And if that doesn't work after a few attempts, I'll start pushing that PCB in the other direction. And eventually the 0-track sensor will align with track 0 and the machine will boot. And that's how easy this process is. Okay, and I got lucky and got it right on the first attempt. I will reboot the machine about 10 times to check for consistency. Okay, so I did about 10 reboots and it works consistently. So the drive from the 7496 is definitely fixed now. By the way, I use an original DOS diskette for this test, because there is always a risk that my copies have been written on a drive with the heads slightly misaligned. So the drive from the 7496 is definitely fixed now. One bad inductor, seized switch, misaligned heads. That's quite a lot for one drive. I obviously did the same mistake when testing the spare drive. The diskette I used wasn't a proper DOS diskette. So I'm going to do this test again and see if I can format the spare drive. Invalid media or track 0 bad, disk unusable. Okay. So we actually have more faults with that drive. That is unfortunately not a head alignment issue. Just out of curiosity, and I guess to prepare a future video, I decided to test the PCB from the faulty drive in a working drive, and it totally works. So the fault must be elsewhere. I want to stay on topic with the 7496 in this video, but we're gonna get back to this drive in a future video and see if we can fix it. Actually, I fell quite deep down the rabbit hole and ended up spending the entire weekend fixing my IBM PS2 double density drives. But I left the camera off to keep the video on topic. But there are a couple of things I want to mention before we move on to the 7496. So first of all, that method to install the drive as drive B to check if it's a head alignment issue. Apparently it doesn't work every time. I have used that method for many years and it has worked every time. But apparently on one of the drives that wasn't true, so there seems to be some exceptions. I wasn't able to format one of the drives as drive B, and yet it was a head alignment issue. It's not clear to me why it didn't work on that one drive. Not sure which one it was, but that doesn't matter. So if that test fails, it can still be a head alignment issue. I also found this very late style drive in one of my machines. It is completely different from the other drives. It has a different set of caps inside. They were leaking like crazy, but luckily the PCB was still fixable. It has some of the traces cut on the edge connector and some added wires. I couldn't find any information about this mod online. I also found a couple of these very early drives here. It looks identical on the outside as the drive in the 7496, but it was manufactured in 1986. And both PCBs are completely different from the other drives. This PCB is completely covered with bodges and added components, glued on top of other components. So definitely some signs of early mistakes when they were designing these drives. The lower PCB too has some added components on top of other components, and some added bodge wires. But the good thing with these drives is that it doesn't use SMD caps, instead it's using regular caps. So I decided to leave them in. And this drive also has a very common fault that I mentioned earlier. There's a shield with a rubber pad that is supposed to be glued on top of the head, and it's very often loose and needs to be glued back on. Also, I realized how incredibly lucky I was to get those heads perfect on the first attempt. On some of these drives I had to move those heads probably about 30 times before I got it right. So be patient when you align the heads. I left this one disassembled because it needs a good wash. So if you know someone who needs to repair his IBM PS2 diskette drive, send them a link to this video. I think we have gone over pretty much anything you may need to know to fix one of these drives. Okay, finally time to disassemble the 7496. I wasn't expecting this video to be a comprehensive PS2 diskette drive repair, but you never know when you start working on these museum pieces where it's going to lead you. This IBM doesn't have a PS2 badge, but it's put together with a mix of IBM PS2 stuff and some custom parts. The badge looks like a typical IBM PS2 badge, but it doesn't say PS2. Instead it says Custom Terminal Executive Workstation. At the back it has an identical badge and a lid to cover up all the cables. So it's clearly designed to look good from any direction. And the display is designed to be viewed from any direction too. The display, by the way, is an at the time extremely expensive Sony Trinitron. So definitely not a cheap and cheerful machine. Aside from the custom paint job and this panel here, the display is an unchanged Sony Trinitron display. And again, the added cover back here is clearly to make the machine look good from the back. To get inside we need to lay the machine down on its side. On the front here there's a sticker that says type 7496 and a serial number. Underneath the machine there's a larger sticker, made in USA, and model number 037-9066. This equipment complies with something or other. Then it also says 1.7 amps, which I think isn't quite entirely true actually, if I remember correctly. And it also says listed EDP equipments 167G. At the back of the machine there is a large opening here for the cables to come out. And it also has a slot down here, presumably for the keyboard cable. So it's clearly designed for really neat cable management, unlike any other machine I've worked on. This machine is disassembled from underneath by removing 2 screws on each side. And with those screws removed, we can just tilt the entire system out, like so. I left it disconnected since I removed the diskette drive. And here's obviously where the drive was installed. And the only cable inside here has handwritten part numbers on it. This connector was cracked when I got the machine, but I managed to glue it back together instead of replacing it to keep the machine as original as possible. The machine also came with this riser here. I store it outside of the machine because of that battery. These are not known to leak, but I will remove it anyways. I don't want to take any risks with this machine. This riser is a standard part, designed for a different PS2 system that has 3 ISA slots. But this machine only has 2 openings at the back. So it also has this custom sticker here that clearly tells us not to use this slot. This machine is assembled with some really weird screws, instead of the typical screws you would find in a PC. And one of them for the power supply is unfortunately missing. One of the blanks is also stuck into the power supply, so we need to remove it. At the back the machine has 1 MCGA slot. MCGA is a very short-lived standard that was briefly available between EGA and VGA, so you can play most period-correct games with this machine. But there are a few exceptions that gets confused by those MCGA graphics. It also has a serial port, parallel port, 2 PS2 ports, and a power connector at an angle. It has been installed at an angle to enable cable management, because there isn't much space at the back here inside the machine. And now we can remove the power supply. The connectors to the motherboard looks pretty standard. But here's our next interesting thing about this machine. Underneath the machine it's stated 1.7 amps, but at the back of the power supply it only says 1 amp. I'll remove this plate too to show you the motherboard proper. And again, very strange screws of many different types. Definitely not something you would typically find in a PC. And this plate is to hold the diskette drive in place. And here's our motherboard. So when I got this machine it had no less than 3 bad chips. U11 and U14. These 2 are custom IBM chips. So I had to temporarily sacrifice an IBM PS2 Model 30 to fix this machine. But luckily I did find a spare board much later, so we have fixed that machine on this channel too. So the machine we used to test those diskette drives was actually the donor to fix this board. And as you could clearly see, it's back into working condition again. This board also had a marginal diskette controller, but that's a standard part, so it was easy to replace. This board actually also has a hard drive controller here, designed for one of these custom IBM hard drives. I actually have a spare drive, and I was planning to install it in this machine with some sort of custom brackets. But since the power supply is only rated for 1 amp, giving us about 100 watts of power, I'm not sure that's a good idea. I definitely don't want to burn that custom power supply. And that brings us to the sponsor of this video, PCB, because we're going to install something that draws a hell of a lot less power than that old IBM PS2 drive. And these are of course XT-IDE cards. Unlike most IBM PS2 systems, this machine doesn't have MCA slots. Instead it has regular ISA slots, so no need for an MCID card in this machine. We can just use a regular XT-IDE. As I mentioned before, the 7496 is not a proper PS2 system, but the motherboard definitely is. There are many XT-IDE cards available, and this one here is an XT-IDE Rev 4 by Glitchworks. The nice thing about this card is that it uses through-hole components only. These boards are super easy to build. I'll start by soldering all the sockets. I installed all the sockets on the card, and then I'm going to put something on top of it, then turn it upside down. This way all the sockets are now flush to the board on the other side. So this is a very quick and easy method when installing tons of sockets in one go, instead of using blue tack or sticky tape. But before we solder those sockets, we need to do an unboxing. So this was quite a coincidence actually. I was working on my car a few weeks ago and I had to repair the main harness in the car. I obviously couldn't remove the harness from the car and repair it on the bench. So I had to bring out my large soldering station, and with some extension cords and lots of hassle, I managed to fix that cable, so the car is fixed. But that also made me realize I need a cordless soldering pen. And wouldn't you know, 2 days later our friends at FNIRSI sent me an email and asked me if I wanted to try this thing out. And of course I said yes. So let's try it out and see if it's any good. So this is not going to be a typical review. Instead I'm going to try it out on an actual project and give you my honest opinion. So this is a FNIRSI HS03 cordless soldering pen. It runs off 5 volts and it has a temperature range from 100 to 450 C. So that should definitely be good enough. It has a 1-inch IPS screen. It is charged with Type-C USB cable, so that's good too. And it weighs only 134 grams. We are informed not to touch the tip, so I'll try to keep that in mind. Now let's cut that tape and see what's in the box. Okay, so it has a carrying case. That's neat. And actually quite useful, since it is designed to be portable. Okay, so here we've got 2 tips. So first we have the HS02B-1. This is a really fine tip. Definitely a useful size. And then we have a curved HS02B-IS. Definitely useful tip too. We've got a screwdriver, a USB-C cable, and then a very simple instruction on how to install the battery. And a user manual in English. Okay, all good so far. Then we have one more tip actually. This is a knife tip, the HS02B-K. These are good too. Then we've got the actual soldering pen. Then we have this piece here. Okay, I connected the USB-C cable and now it's charging. This thing here is to protect the tip. I'll let it charge for a few minutes and then we'll try it out. After having pushed the OK button once, I get to choose between English and Chinese. Let's go for English, Celsius. And now the display says OK, with 2 arrows pointing on the OK button. So let's push it again. Okay, and it fired up, running at 250. Okay, and it's heating up really quickly. Temperature is set to 250, and it only took a few seconds to reach that temperature. Let's crank it up to 380, and it only took 1 or 2 seconds for it to reach that temperature. So I think it's ready to use. I went with a knife tip. Yeah, this is totally working. So first impression, it fires up really quickly and reaches the desired temperature in just a few seconds, so that is more than good enough. And when I put the protective cover on, it stays at the set temperature. So I guess it's designed to be used instead of a stand. That's pretty good. I like what I see so far. The protective cover, by the way, is magnetic, so it snaps into place. And as expected, this is totally working. It heats the pad and the pin up very quickly. I was a bit worried that it was so large, and that is of course because of the large battery inside. But it actually doesn't feel that clumsy. It sits quite good in my hand. It's also not very heavy. So this is pretty damn good. I wish I had this thing when I fixed my car the other week. That job would have been so much easier. Well, this isn't going to be fun to watch, so I'll solder all the sockets here and skip ahead. Okay, so I have done what must be a couple of 100 solder joints now. And it's working perfectly. Very nice and stable power. No issues whatsoever. So yet another excellent tool from our friends at FNIRSI. And if you do any type of work in the field, or if you're a petrol head like me, then definitely check out the FNIRSI HS03 cordless soldering pen. Actually, this card was so easy to build, I decided to skip ahead here. The bill of material is available at GitHub, and I even found a pre-configured file for the ROM. Also, I used some angled pin headers for the IDE connector. That way there should be room enough for the compact flash card inside the machine here. All the jumper and switch settings here were also easy to find. And all these components are standard components. So everything should be available at your favorite electronic supplier, or on AliExpress if you wish. Before we can install this card, we need to make a small mod. The compact flash card can be powered in two ways. So either by using a Molex cable, or by feeding power through pin 20. This is hard to show on camera, but this card here is actually missing pin 20. So that method won't work. And the power supply in the 7496 doesn't have any Molex cables either. Luckily there is an easy fix for this, because this card has these two pin headers here, J4. And according to the silk screen here, we can install a jumper here and feed 5 volts to pin 20. And since we're missing pin 20 on the compact flash card, we can instead install a jumper wire and then feed 5 volts directly to the compact flash card. And with this simple mod, we now have 5 volts at the compact flash card. And there is no need for the Molex cable. I have installed the card in the third slot here. Since this card doesn't need a slot opening back here, we could in theory remove the sticker here and install it in the first slot. But I'm obviously not going to do anything destructive to this museum piece. Well, DOS gaming is no fun without sound. So in the second slot I'm going to install this AdLib replica card that we have built in a previous video. Now this riser is actually a standard PS2 part, so we could temporarily replace it. But I don't really need any more cards in this machine at the moment, so I'm just going to leave it like this. And I am of course going to remember to remove that battery before I store it again after a short gaming session this weekend. The display has the original power switch from Sony, and this power supply senses when the display is turned on, and then it turns the machine on too. And if you're feeling adventurous, you could always try to start it with a paper clip. The cable from the display doesn't quite fit this connector here, so they just bodged it together like this. I have disassembled it and tried to install it proper, but it's just too thick for that connector. The diskette drive is covered up by a standard PS2 bezel, but there's no way to mount it in the lid. And there's no way to install it on the chassis either. So all we can do is to place it like this, and then very gently put the cover back on. The cover will then push on these two tabs here and hold it firmly in place. But this is very poorly designed. So one of several clues that IBM never really finished designing these machines. I think this bezel here came from an IBM PS2 Model 30. There are just two really thin plastic tabs holding the display to the chassis here. And when I got the machine they were broken off. I have glued them back together, but it wouldn't take much to break them off again. Getting that bezel in position is quite tricky, since there's nothing holding it in place. So I'm just gonna have to redo this until I get it right. And even when correctly installed and all the screws in, it still sits quite flimsy here. And this lid too. This is very unlike IBM. So the design has not really been refined. They must have ended this project before they finished designing this machine. Well, there's only one obvious choice of game when testing this machine. Okay, here goes. And it counts up 640k of RAM. This machine, by the way, came with an unboxed brand new IBM Model M. So more PS2 stuff. And it boosts the DOS from the compact flash card. So that mod worked too. Awesome. Now let's do a final test of that diskette drive. Yeah, it seems to be working. Well, I have restored countless of IBM systems, and unlike this machine, they all have a few things in common. Really well designed with premium parts, and the fit and finish is spot on. So I think it's a pretty good guess that these machines are either prototypes or some kind of proof of concept, with a mix of PS2 stuff, custom parts, and a very expensive, slightly modified Sony display. Well, whatever they are, I think it's a really cool machine. IBM's this rare don't come around twice, so I'm glad we could fix it, and I'll make sure to keep this one alive. And that's all I have for you guys today. Before you leave, like, subscribe and leave a comment, and consider joining me on Patreon. And I'll see you guys again next week.